Okay, but we will start going over it. That means that this test will be close to the beginning of next quarter. Okay. So chapter 3, this is section 1, reading graphs in rectangular coordinate systems. So it's going to be a little bit more graphing lines. Okay. I'm going to do it using y equals mx plus b, which is also the slope-intercept form is what you'll hear it called. Okay, so I'm going to do it that way. View an example will tell you to make a table instead. I am preparing you for later stuff rather than making you make a table. Okay, so if you remember last year, you were told to do -1, 0, 1. Y'all remember that on the x's? You can do that, and that will create a line, but I want you to, I would prefer if you start preparing yourself for these bigger problems, because these bigger problems will be easier if you can do y equals mx plus b. All right, so reading graphs and rectangular coordinate systems. So here's today's objectives. We're just going to jump right into it. Okay, reading graphs, pretty simple. A lot of you have been making graphs with me in science, so this should be a nothing part of the section for you. The bar graph to the right shows the top 10 countries that tourists visit each year. Estimate the number of tourists per year whose destination is country B. So let's look where country B is. Okay, country B. If I draw that line, you can see it's a little bit below 45. It's a little bit below 45, so what they will probably do is they'll do, on the website, it'll do 44 plus or minus like 2. Okay? Your answer can be anything in that range. So my answer would have been 44, but yours can be anything in that range. So 43, 44, 45, 46, 42. All of those will work. Okay? Because it's giving you a little bit of range because it's not exact. It says estimate. Okay? So it won't count you wrong, and neither will I on the test. Okay? You just got to know where you're looking. Okay? So on this one, the following line graph shows the attendance at an annual event from 98 through 2004. Estimate the attendance at the event in 2001. So at 2001, if we look at the bottom, the 2001 dot is this one here. Okay, that one, if I drew a line straight over, it's not exactly on the 60,000 line. 59,000, you mean. 59,000. And again, that will be plus or minus. So 59,000 plus or minus 2,000, or around that. Okay, so if you gave me 49,000, like he accidentally said, that would be way down here. They wouldn't count that, right? That's not close enough. Okay, they might count 40 or 55, maybe, but that's getting a little bit off. Okay, so just keep that in mind. It is an estimate. I know it's an estimate. I know not everyone's going to be exact. I will let you know that they're probably not going to. Did I touch the screen?
Sorry. Yeah.
Very silly song.
So, silly songs with Larry. Okay, so I know it's an estimate, so I'm going to count it, but probably shouldn't give me a very, very, very specific estimate. Don't give me 59,136, right? Round to probably the thousands place on this type of problem, because that's what the graph is going by anyway, okay? All right, up next, x and y coordinates. Find the x and the y of point C. Okay, remember on x and y, x before y, you run before you fly, okay? So x before y, you run, you go sideways before you go up and down, okay? So what we want to think about is point C. And we ran 3, and we flew 4. So 3, 4. Okay, that's point C in that spot. This is a weirdly missed problem on the test. Okay, It is missed a lot, and it might be one of those ones where we're just so comfortable with it that we go really fast. Okay? So we always go sideways first and then go up and down. Okay? So 3, 4. It does need parentheses. It's an ordered pair. Okay? It does matter the order because it's an ordered pair. So you have to put it in the correct order as well. Another question that they could ask that's not on the notes is what quadrant is that in? Anybody know which quadrant? Quadrants meaning each part of the graph.
Five.
Okay, so you can see this is called a coordinate plane. Okay, on a coordinate plane, the quadrants make a C shape. So this is actually quadrant 1. Okay, it goes 1, 2, 3, and then 4. Okay, so that is in quadrant 1. A lot of people think it's 1, 2, 3, 4, right? Okay, that's what a lot of you were telling me too here because you were doing that. It goes in a C shape, so 1, 2, 3, 4. Okay, so this is in quadrant 1. All right, up next, determine whether the ordered pair is a solution to the problem. We've been doing this a lot, but now we have an X and a Y, so we have to plug both of them in. My only rules about plugging stuff in are what? Anybody remember? When you plug a number in, write the whole equation.
Use parentheses.
Use parentheses if it's negative or next to, okay? If it's negative or next to something. So if you're plugging in any negative, like this or this, put it in parentheses. If it's next to something, so anything we're plugging into Y, we want to put in parentheses as well. Okay? So plugging in 0, 0, so that is your X and your Y. So 0 equals negative 2 over 3 multiplied by 0. So that is 0 equals 0. So yes, that is a solution. So check. Okay, and again, we're doing this in order to use this information later to check our problems. So when we are solving for X and Y, we can check them using this same thing. Okay, so if we plug in 2 and 3, make sure you plug them in the right order because on the homework, some of the ones on the homework say Y first. So Y equals, right? Y equals mx plus b. So they don't always go in the order of my ordered pairs. You have to make sure you plug them into the right letter. Okay, so X and Y. So my X is 2, negative 2 over 3, and my Y is 3. It's actually really nice because we're multiplying by what's on the bottom, so those 3's cancel, giving me 2 equals negative 2. That one does not work because 2 does not equal negative 2. Okay, go ahead and plug in those last two problems. Both of them have negatives in them, so you got to put them in parentheses, those negatives at least. For the first one, when we plug it in, that is 4 equals negative 2 over 3, and then Y is negative 3. Okay, a negative times a negative equals a positive, and the 3's cancel, so then we just have 4 equals 2. So that first one is no, and that should be an arrow. Okay, last one, negative 2 equals negative 2 over 3 multiplied by a 3. The 3's cancel, so negative 2 equals negative 2. That is a yes. So there are our answers. Okay, again, that is going to be very important later because right now you might do the problem and be so confident that you got the answers that you're not checking, which I would highly advise against because everyone makes those mistakes. But later you will be required to check. Okay? That it will not work every time. So you always have to check, even if you solved it perfectly. So we need to get good at that. Okay, this one is also one that I see a lot on tests. It says determine whether or not the ordered pair is a solution to the given linear equation. Okay, here's my linear equation. This x equals 3. This is exactly like the one above. Exactly like the one above, it's just our equation's a lot easier. It's just x equals something. There's no y. So if there's no y, then it doesn't matter what our y's are. It only matters what our x's are. So I'm going to cross out my y's. And now we just got to figure out if we plug in our x's, does it work? So on that first one, does x equal 3? Yes, on this first one, x is a 3. On the next one, does x equal 3? No. On the next one, then the x is 0. On the last one, does x equal 3? Okay, very simple problem. I believe it does end up on your test, and it tends to confuse people, just because there's no y. But if there's no y, then you don't have to think about y. Cross it out completely and just look at these. Okay? You don't even have to plug it in. You just have to tell me, does x equal 3? Yes. Does x equal 3? No. Okay? All right, next one. So, exact same thing. We're just plugging stuff in, but now it's in a table format. Okay, but we're still just going to plug it in. On this first line, they've given us an x value. So that means we want to plug it in to figure out our y value. So on that first one, that is y equals 1/2 0 plus 4. Okay, 1/2 times 0 gives me 0, so y equals 4. There's my first one. Okay, same thing on the next one. Just plug it in. If it's negative or next to, you put it in parentheses. So y equals 1/2 negative 4 plus 4. Okay, 1/2 of negative 4, which is the same as negative 4 times 1 divided by 2. So negative 4 divided by 2 is negative 2. So negative 2 plus 4 is y equals 2. On the last one, they've given us a y, so we'll actually have to solve it a little bit. So if I plug a y in there, that is 0 equals 1/2 x plus 4. We do have to solve that equation. Okay, in order to solve it, we undo the addition or subtraction first. So subtract 4 from both sides. Minus 4 minus 4. So negative 4 equals 1/2 x. You can multiply by the reciprocal here, or you could multiply everything by 2 to get rid of the fraction. You could have also done that at the very beginning. Multiplied everything by 2 to get rid of the fraction at the beginning. Okay, so if I multiply everything by 2, that would be a negative 8 equals x. Because 2 and 2 would cancel, so that would be just a 1x. So negative 8 goes here. Okay, and you can see that that does follow a pattern. That is because it is a linear equation, which makes a line. So it does go in a straight line. Yes?
Do we have to work out the equation if the pattern is obvious?
Yes, because the pattern won't always work. And so I want you to get in the habit of doing this, because later they won't be y equals mx plus b's. They won't be straight. They'll be curved, and it'll look like a pattern. So like if x goes down to negative 4, it might come back right after negative 4, and you won't know unless you test the next point. On these, it will most likely follow a pattern, but just so that we get into the habit, let's work it out. Okay, last thing is correlation. All right, correlation. There's no writing to be done on this. Just listen. Okay, which direction? Correlation is which direction the graph is going and how spread out it is. Okay? How we describe that is something called the correlation coefficient, which is R. Okay, it's described as the letter R. Okay? So down here, the way that you describe correlation is whether or not you can choose where the next point would be. Okay? So if I asked you to tell me where the next dot would be on this one, on A, you could probably tell me almost exactly where that next point would be. It would be on this line, because that is a perfectly straight line. So you could tell me most likely that dot would be like right there. Right? So R is 1 here. 1 means that it's perfect. Okay? And the further away from 1 we get, the more spread out we are. Okay, so on this one, you could kind of guess where the next dot would be, but you wouldn't be able to tell me exactly where it is. You can see that it does still follow a path, but any of those dots would be okay to be the next dot, because it doesn't actually tell you exactly where it's going to go. So that's not exactly 1, but it's still positive. Okay? And the reason it's positive is because it's going up. So if you read it from left to right, if it goes up, that's going to be a positive number. Okay, the next one, still has somewhat of a trend, right? We could still know that this dot's going to be somewhere up here, but it's really spread out. So 0.3 is our R on that one. Yeah.
How do you even get the number
So for R, there are ways to solve it, but basically right now I just want you to know what R should stand for. And the further away from 1 it is, that's how spread out it is. Okay? So like on this one, there is nothing. You could not tell me at all where that next dot would be. It could be literally any spot on this, and it would look just like the rest of it, right? So there is zero correlation between that. Yeah?
I know, like, how would you get 0.3? Like, why is it only 0.3? Like, could you do 0.4?
Yeah. 0.4. That's what I'm saying. Like these, it would be more like a multiple choice problem right now, because we're just introducing the concept of correlation. Later it might be a little bit more detailed than that. So what correlation, you may have heard the phrase correlation does not equal causation. Correlation means these two things respond to each other in some way. Okay? So if I had, you can look up online weird correlations, and it could be, some of them are like really weird. They're like number of Nick Cage movies every year compared to the number of suicides. And it looks like it follows a trend, right? But that's just correlation. That just means that they match. Okay? It looks like it follows a trend, but that doesn't mean that it caused that, right? The movies do not mean that it caused it. Something else that's correlated is ice cream sold versus the temperature. And that is causation. But it also is correlation. So the graph shows you if these two variables, whatever they are related in some way or appear to be. Okay? And then down on that bottom row. So same thing, it's just they are going down from left to right. So you could tell me where this next dot was, probably down here somewhere. But it is going down, so it is, that was weird. It is going down, so it is negative. Okay? And again, yes, 0.3 is just telling me, yeah, that's pretty spread out. Okay? 0.8 means that it's a lot more compact, but it's not perfect. It's not a perfectly straight line, but it does go down. So make sure that you pay attention to whether it goes up or down. Okay, it goes down, so negative 0.8. And then the last one, you can tell me almost exactly where that next dot would follow. So that is a 1, but it's going down, so it's a negative 1 on that one. Okay, that's correlation. Correlation, and most likely, yes, that would be a multiple choice type problem. So it might say, which one of these graphs represents a moderate or weak correlation? Or moderate or weak positive correlation? Or it could say, which one of these graphs probably represents a 0.4 correlation? Okay? All right, so that's the end of section 1. Is there anything you need me to go back to? A lot of it was not very much working out, but just concept. Okay, we already knew how to do all this stuff, except maybe this. That's the only new thing today, new thing that I have said. The rest of this is still just plugging stuff in. You just have 2 numbers to plug in now. Okay? All right, slide break, and then we'll jump into the next one. I'll post this first assignment for you.